Yeah, I would love to hear about it. Just let me know when we're live.
Yeah, it's starting right now.
Got it?
I'll go. I think we live.
Cool. Woo. I will move to here. Hello, everyone. Welcome to another episode or rendition of the Plasma demo. It's me, Stefan, and Lewis.
Thank
How
you.
you doing, Lewis?
Doing pretty well. Yeah, just returned from London, back to Barbados.
Nice. How was your trip?
Some turbulent, but overall enjoyable. Overall enjoyable. It's quite a vacation. I think it's mainly of a vacation. Got me to explore London a little bit, having fun, and then also meeting a lot of founder in the area. Right, with Stefan and I was actually meeting a bunch of founder in the London area last 2 weeks. Have
Yeah,
some
yeah,
good chat.
it was really good.
Have some good partnership out of that. Have some good. I mean, we also have a lot of huge stuff we coming up or coming up. Yeah, there'll be maybe there might be some announcement in the next month or so. Excited for that.
Oh, yeah. Yeah, super excited about the announcement as well. Yeah, like Lewis said, met with a lot of founders. Honestly, I feel like London has a pretty good startup scene. Like we met some really cool founders the last couple of weeks. So that was really awesome. Yeah. So one of the founders we met is actually of Sigma OS. So um, if you go to ihatemybrowser.com, that'll take you to, or you can do sigmaos.com. That'll take you to Sigma, and it's a browser. So it's this new kind of browser where it groups things in different ways. So if you've been using Chrome or Brave, it's a little bit different than that. Yeah, it's pretty cool. But basically, we want to see how we can So one of the things that I set as a challenge for myself was this Saturday. Let me see if I can actually use my cybersecurity knowledge and do some cool stuff with Sigma. So I actually wanted to okay, this is like my dream. My dream is to be able to load Sigma OS up, have it load an extension that I give it, because it can actually load Chrome extensions, which is really cool, even though it's WebKit based. And then the final thing I wanted to do is I wanted to go to a website using the Chrome extension, like the Chrome extension is running in the background, what I mean. And then the part that I really want is to be able to inspect the console and inspect all of the web views. So like the main web view as well as like the pop-up view and so on and so forth. So that's kind of like what I want to have happen. So we have that working with like Chrome and Firefox, super piece of cake, because like you have tools like Playwright and Puppeteer, and basically all this functionality is built into the sort of browser, but Sigma doesn't really have that functionality. So we're working with them a little bit on that. And I just thought like maybe it would be cool if I do some like process injection or something of that sort to hack through the browser and get it to work to do what I want. So that's what I spend my time on. And yeah, basically did like, yeah, this is like Ghidra, like some reverse engineering to see what they were doing. It's all like written in Swift, and then yeah, like messed around with IDA, found that they were using like WK WebView and so on. One of the interesting things is like I actually haven't I haven't really made any Swift apps or done much stuff with Swift or Objective C, so all this stuff is pretty new to me, which was really fun because I got to learn a lot of cool stuff, especially like how, like, you know, so WK, I believe it stands for WebKit, so it's like WebKit, WebView, and so on. And yeah, it was pretty neat. So one of the things that we got working was okay. So I did some work there, and I was like, okay, there's two pathways here. One of them is like process injection, which is like actually injecting into this process that's running, like this browser process, and then like putting our own code in there, hooking function calls and having them return other things, or like intercepting them to get to like sniff data out, right? Like imagine when I do like inspect element here, right? And I do console, these are, this text shows up because Brave browser, with a process for Brave browser, called some function to get this text. So imagine you know what that function is and you know what module it exists in. You can actually like hook into this process and then change that function to also say like, oh yeah, you know, you can definitely return this text to the Brave browser process, but before you do that, actually like send it to this other process that's like listening, and then that process would show it on my console, or like I can programmatically access it. So that's kind of the idea. And then so like that's like the process injection part, and then the other part is actually using Automator or Apple scripts. So one of the really cool things is like I actually had no idea this existed. So I knew about Apple scripts, but like there's this thing called dictionary. So when you open a dictionary, it shows you all of the like applications you have on your computer. And when you click on Sigma OS here, I have a lot of them, but I'll click on this one. You'll see that like there are certain things you can do in Sigma OS, and unfortunately, I can't make this bigger, or maybe I can. But you have this, so here's a Sigma scripting suite, and they have different nouns. So this is like a dictionary, which is a really interesting concept. So you have an application, you have a window, and you have a tab. And then the cool part is like you can actually interface with them using this like Apple script language. So here, let's see if I can increase this. Yeah, it doesn't look like it. So I can actually say like tell application Sigma OS activate, which means put it into the foreground, or like I think open it maybe. I'm not an expert. And then open location google.com. And when I run this, Sigma OS will actually execute and it will open google.com. So let me do that right now. So Sigma OS opens and runs google.com. And this is all possible because Apple has this like abstraction on top of views. So like I think the idea is like if you have a web view, it will automatically like set this stuff up for you, which is awesome. And I think that there's like maybe some other ways to do it. I don't know if they did this manually or not. I'll have to talk to them about that, but I think it's really neat. Now, the thing about this is like we can programmatically do this. Like we can run this Apple script programmatically and stuff, and we do that for the testbed suite that we have, which offers test flight for Chrome extensions. It's a paid feature, so if you sign up for the waitlist, you can get access to that. But so like we already know about Apple script and we know how to run it programmatically, but the thing that we really want is like more fine-grained control. You know, it's nice to be able to open up tabs and stuff, but what we really want is to be able to like look at the console and like figure out, you know, what errors are going on. We want to look at the HTML of the tab and stuff like that. And unfortunately, we don't really get that kind of fine-grained control using AppleScript. So instead, kind of messed around with Frida. So Frida is really cool. Basically, Frida, and I think mostly mobile reverse engineers use Frida, but it can also be used for like Mac. And the cool thing about it is it's a kind of like a, what's a way to describe it? It's sort of like a suite or like maybe like a toolkit for kind of process injection. So here, let me show you guys an example. So I have Frida here. So I have this hello world.c file. So let me open this up. Syntax on. Okay, so I have this function here called Bob, and this function returns the number 4. And then I have the normal main function, and I have here a is equal to Bob, and then I print a, and then I print hello world. Right, that's all it does. So if I do like feeling hello world, then it generates like a dot out, hit 4, and hello world. But then I think so
So what are you trying to do, by the way?
yeah, okay, so the idea here is like we have, so when I do a dot out, like when I run this, it prints whatever Bob, the function Bob was, right? But the cool thing about Frida is you can actually like basically hijack the process to make a function be whatever you want it to be. So I think, so I made this a while ago, which is why I need to like, let's look at it real quick. All right, I changed this stuff up. Yeah. So if we do Bob here, so this is the cool part about Frida. Let me increase this. Okay, so what you can do is you can implement like on leave and on enter and also on message. So here what we're doing is we're saying on leave, I want you to replace the return value with 1. So like this is like a lot of sort of, you know, you can ignore like this, like all this other stuff, but you just need to see like replace return value with 1. And so now, and then what I'm doing is I'm saying like, hey, can you please create this this like open implementation, and I want you to search using the default search algorithm for the function called Bob. I want you to search for this function, and then I want you to attach this interceptor. And what we're doing is we're creating this like listener, which is like having this on leave function. So what we're saying is like when this function exits, we want you to replace the return value of the function with 1. So if all goes according to plan, and I compile with this gigantic code block, should work. I just need to change this to, let's see, main undefined. ARM64. Hmm. Okay, well, so, okay,
Can I see the Can I see the whole command again?
yes.
I seem to have everything.
Yeah, I'll take a look and like fix it, and then I can show it in the next demo. But the core idea behind something like this is basically like you can run a process and then change how functions in the process behave, and you can like manipulate them. So it's sort of Rita is sort of like a black box changing of like how the process functions, where you don't need to necessarily understand how the entire process functions. As long as you know like what key functions you need to change in order for like the process to like do what you want, then that's all you need to know. So what's really cool
So
is like, yeah, go ahead.
yeah, so does the function has to be defined within the program? Like you have to find them,
Yeah.
or is it like,
Uh,
it can be anything?
so you usually like so like for example, one of the things that Chrome does, right? Like when we're building the test flight for Chrome extensions, one of the things that I was playing around with back then was basically Chrome to check whether like so like Chrome checks whether you have like a web store as a trusted web store, and what it does is it checks this like value that macOS has called the CF. Yeah, right here. CF preferences app value is forced. So what this is saying is like, hey, there's this preference file that you have like that like I'm requesting. Hey Mac kernel, can you let me know whether this value was forced, aka did an admin put this in place, or was it something that like the user put in? And if it's not a managed profile, then this will be false. And then what happens is Chrome will say, oh, it was false. I'm not going to enforce this policy, and so on and so forth, right? So one of the things I was playing around with back then was like, okay, well, why don't we just write this like little thing that'll patch Chrome, where whenever this runs, it will default to true. So that's why there's a 1 here. So 1 is true, right? 0 is false. So the idea behind this was like, you know, as long as this is true, then Chrome will happily read the correct value, and then be able to like trust web stores. The issue with this is when you're doing process injection, Apple actually introduced a new thing called a hardened runtime. So when you're doing code signing, you can flip this flag on, and it will enable hardened runtime of your application. And if there is hardened runtime, it actually makes it impossible to do process injection into the application. So the way to kind of combat this, and what we did with Sigma OS, is you can actually like strip the code signing and then re-sign the application. Unfortunately, it won't work if it's like on the applications folder, but it'll work if it's on a random folder like what we have here. So that's just something to keep in mind. So I'll show like the example of show the example of like kind of doing process injection with the Frida CLI using also the JavaScript SDK. What happened? Here we go. So I can do resume. So basically, whenever you run this extension, whenever you run this like Rita CLI, it'll start the process, but it won't. It will like basically imagine you have a debug breakpoint at the first line of code. That's kind of how it is. We just want to resume it. now it's going to start Sigma OS, and we are inside. So we can actually do cool stuff where like we can reference Objective-C and do like classes. And now we can get all the classes that exist in Sigma OS. So what we can do is we can do cool stuff where like, let's say we have like a NS, it's like, I think it's like NS window or something like that. Yeah, like there's like NS document revision window, and like, where's like NS window. And the cool thing is like, so there's this company called NowSecure. They do a lot of cool stuff with Frida, and I think they're one of their main sponsors. But they have this thing called Frida UI Kit, and basically Frida UI Kit, it lets you, like, it's a JavaScript like package, and it's really cool because it actually lets you manipulate UI right away. Like you can do await UI.get node type UI text field, and then now you can do like set text John Doe, and you don't have to like think about process injection or anything. It all abstracts it away, and you're able to actually manipulate web views directly through Frida. So it's super cool. So like we could literally do that. Like if we're like, this is, by the way, this is all JavaScript. We can do that here if they were using UIKit, but unfortunately UIKit is a mobile thing, and NowSecure is like a mobile kind of company for mobile apps. So I think the path forward, which I haven't gotten to, is to be able to kind of like take this like file and just convert it to using the Swift UI sort of stuff. So you see they use Object-C dot classes dot UI view. So this doesn't exist here because it's not a mobile app. So like, you know, a UI view kind of thing. Whereas NS window, it is a thing. And then like I think there's like some like UI stuff, but I'm not so experienced in like Mac programming, so I still need to do some research. But that's the general idea. Like, yeah, I'm not sure what it is, but that's kind of the path forward. And then what we will be able to do is like, not only will we be able to get these certain things, but like these certain UI nodes, but they also have this amazing thing called, where is it now? It's like web view or something. Yeah. So Frida UI web view actually uses Frida UI kit. So you can get the web view, and then now you can actually do like web.get. You put in a web view, and then you can like make you can get like the one that has login to Spotify, and now you can actually perform like DOM. You can actually get stuff from the DOM. So you can do like .click, and it'll actually click, and so on and so forth. And when you look at the code, they actually have have JavaScript that runs within the context of the DOM. So we would be able to like completely do whatever we want within the DOM. And we they have set element text script, whatever. So we can just inject whatever we want into the DOM. So like once we get that, like we can basically do whatever we want. But yeah, that's the general idea.
And then would this apply to like Safari, for example, Safari browser? Because Safari is WebKit,
exactly, right? Yeah, definitely. This would apply to Safari. I think literally anything using the WebKit web view will work.
Interesting, yeah, because there's actually, I think there's a slide missing. There's a slight lack of tooling in terms of automating Safari testing, right? Also Safari extension, but even then, Safari browser testing is like a huge missing pieces for a lot of people. Like most people just testing on automation testing would running on Chromium, and maybe Firefox with Playwright.
Exactly.
But yeah, Safari as a target has yet to be explored, I think.
Yeah, that's true. So I think we can hit two birds with one stone, going with Sigma as well as Safari. So I think that'd be pretty sick.
Yeah, one thought I have is.
Yeah, just one thing to add though. I think Puppeteer, like Playwright, have WebKit browser, but I'm not sure what that is.
Probably.
Yeah. Is that like a web view, or is that like an actual browser or Safari? I'm not sure.
Hmm.
But yeah, that's pretty much it. And yeah, like maybe for that demo of the C code, I can like do it next week because I think there's something wrong with it. So I'll try to figure that out.
I think you're right though. Actually, yeah, Playwright actually have WebKit, and they use a base WebKit to build Safari. Yeah,
They use WebKit.
they use WebKit. Yeah, they have WebKit.
Got it.
Hmm.
Essentially, like use, yeah, there it is. So yeah, I don't know the exact syntax, but yeah, you can use the Frida CLI to do this as well, to change the stuff in JavaScript. They really improved this. I think last time I was using this, I had used C and it was a nightmare. So I'm really glad they introduced. They even have TypeScript bindings and stuff. It's pretty awesome. But yeah, that's pretty much it.
Nice. How does Frida like basically how does it inject like script inside process? Is it like
Okay.
adding like a sleep binding or something? No, like because so when I was actually doing some research on how to, so yeah, I was doing some research on like how to de-async a Node.js process, and there's actually a de-async package that basically does a stop. So basically, if when there's an asynchronous process, it does a thread sleeping to kind of emulating the synchronization, and then appending the process, the async process in between, and then stop sleeping on the main process.
I see. Oh, I see.
So
Okay.
yeah, so how does Frida does that? How does it actually injecting process? It's supposed to be injecting some logic between the process, right? So like
Yeah.
basically you try to decompile the original app, you find some entry point where you can inject your code, right? And then when you found some entry point, you were injecting some certain logic. Is that like kind of the gist of the Frida suite?
Yeah. So there's this entitlement that Mac has, which is called task for PID. So like this is what you can use to basically do process injection. So in terms of like how does it like inject and like do those fancy like things, I knew that 3 years ago. I don't remember anymore. But there are two ways. There's probably more, but the two ways I know that it does it is this thing task for PID. So like it's able to, yeah, so it was, so prior to, it was completely legal for one process to control another for a purpose of influencing its execution. So I think the idea is like what Frida does is it can inspect a process's memory, and then you can do whatever you want, right? Like it can parse the memory to figure out like what the function names are, and then like you can search the function names. Like this is what we did just now, right?
Mhm.
Like in this example, like the hello world. Like if I do like module dot like enumerate exports, for example. Just do like find exports by name, right? And I do Bob, which is our function. And then I do null for like find everything, not like basically what this says is like what module do you want to find it in? You just say null, which means I want to find it in every module. It points to the memory address, and now like Frida can take that memory address and add its own thing into it, you know? So the way it does this at the moment is using task for PID, but then there's this other way of doing stuff, which is actually this thing called UILD insert libraries. So have you ever done LD preload before on Linux?
Nope.
So LD preload, the idea behind it is like you can actually inject libraries.
Oh, you're talking about, is it C++? Is it C++ kind of concept?
It's like
or is it
Linux, yeah. Yeah, I think like C++ might use this in like C and stuff as well. But the idea behind it is like, it's like a, you can run things within the context of the application, which run in the same like memory space. So in this case, Frida has this thing called Frida Gadget. So if you can't do task per PID, you can do this UILD insert libraries thing, and then you can send the dilib into it. And what's really cool is like, let's say we run this, right? Frida will actually like spawn, and we'll start listening on localhost on this port. And then when we go to another like terminal tab, and we run Frida on this like process, Sigma OS process, it's actually going to use the UILD insert libraries like Frida Gadget to inject if we don't have this thing. So like this is useful mostly with non-jailbroken devices, or like where you don't have like root, or you don't have permissions to like do task for PID. And you can't do process injection traditionally. Then you can use this like gadget trick. So yeah, those are I think like two ways it does it. But I think like in terms of mechanics, it just looks at the process memory, like understands the structure of like the process memory, and then is able to like replace things and like actually patch like the machine code. Yeah. So, by the way, malware loves using this, because imagine you do process injection to Brave, and then your malware runs within the context of Brave browser or like Chrome. Then literally every security team won't see anything, because like whenever they get like the process logs, right, to see what process connects to what and so on and so forth, yeah, Chrome connects to this like website, yeah, that's fine. Like if you have a company with like 10,000 people go to like so many different websites, so it's not at all anomalous. Whereas like imagine like Microsoft Word or Excel connected to like some random domain, now that would be sketchy, right? So like if you had like a Word document that had like some sort of like malware on it, you would want to like figure out how to get execution on the host, and then do process injection into like, I don't know, like Spotify or like Brave or Chrome or whatever, and then actually call out to your command and control server. So that's like some trivia. But yeah, that's pretty much it. Louis, you wanna talk about Zig?
Sure.
I'll share my screen.
Fun stuff with the reverse engineering, debugging, and process injection. So let me do some screen sharing on my end as well. I think I have a mosquito visiting me.
Oh no.
That's annoying, but okay. Oh, all right. So there's my screen. Let me just remove. Trying to reorganizing. By the way, I think there's echo coming from your, coming from you.
Okay, I'm muted.
Thank you. Oh Lord, let's screen share again. Okay, sharing my screen. All right, should work now. All right, so one of the thought that we discussed last stream is actually how to use Zig to creating a WASM binary, because so WebAssembly allow you to run native code, or like WebAssembly code, right? which would allow you to have like code that run at like native performance on your machine, using a web browser or using any kind of JavaScript or any runner, any engine that support WebAssembly. And so one of the things that we investigated last week that we want to do was actually to just trying out Zig and how to use Zig to compile down to WebAssembly. And the journey so far, I spent about 2 days with it, since actually 3 days. So since Saturday, been playing around with Zig, setting up environment. The environment setting up is very, very trivial, very, very simple. Zig has kind of a very, very similar philosophy to, I think, at least in terms of their way of building binaries, very similar to Go actually, which is the whole everything is tightly kind of the build system, allowing you to build like an executed kind of binary blob, and you just throw that around, people can run it. And so that's why Zig is very, very. That's why I think kind of one goal of Zig is to eventually become fully bootstrapped, right? Stage 3 is Zig compile Zig. Right now, Zig is on stage 2, I think, which is the C compile version of Zig, compile Zig to make Zig. The next version is Zig compile Zig that make the final Zig version. So everything is basically, it's like the snake bite itself and swallow itself into oblivion, right? So so right now Zig I think is in stage 2 for their compiler, which is I think based on what I've been reading so far, but I might be wrong actually, because been on this for 2 days. So Zig itself has a lot of Zig is shipped as a binary, and Zig has a lot of command. The build basically Zig build basically run a
Pause Louis, sorry to interrupt you. Your terminal is cut like we can't see the left portion of it, so we don't see most of the commands.
Alright. Here we go. This should be good, better, right? I have a lot of tab going on. Yeah, this should be better, no? Alright. So let me also make the screen bigger. So the Zig, so when you installing the whole Zig toolchain, you just get the Zig binary, which is the Zig compiler and also execution and also Zig formatter. It's like Plasma. It's like a Plasma command with a bunch of shit inside of it. A single binary that has a bunch of subcommand that you can run. And Zig build basically executing a build.zig file with an entry point inside called a build script. So you can actually at its core, the Zig toolchain was made to tailor toward actually making a build script actually, and you would use it to make a system, right? Zig is the system language, so you would use it to build like more intricate low-level system. So it's actually pretty interesting that the first command that it offer the user is actually a command to run a build.zig. So you can now actually kind of composing your build system using Zig itself. So you basically, for example, in which is I think one of the reason why JavaScript was very successful, because people actually just making or Node.js was very successful because to making a build script, they just make a JavaScript script that would run stuff that they need to do. So that's essentially what Zig is doing here with this Zig build. So let's take a look at the anatomy of a very simple Zig build I just created for our new with Wasm Zig extension. So Zig is like kind of similar to C with the syntax of like Go plus JavaScript. You importing the standard library, and then here, so for the build.zig file, you would have a public build function that will be invoked by the Zig binary itself. And here there's a certain structure to how you would specifying your build.zig file, but essentially you're specifying entry file. You're adding a shared library, or you can adding a library. You can also adding so there are 3 type of things you can add to your build to your build script, you can add executable, you can add library. You can add other stuff too, but like the three key things are executable, library, and header for your kind of for distributable library. And some of these things I have not like kind of explored them too much, but hey, for 2 days, that's all I have so far. Zig as a language, it's pretty okay. It's pretty lightweight. I think that's the main reason I like it. It has a lot of shortcut for a lot of stuff. For example, this dot inversion, right? This is actually an enum referencing the expected enum coming from this. So over here, right? You seeing suddenly, hey, what is this dot inversion thingy? Like, it's not referenced anywhere, right? So, and also this dot release fast, right? What the hell is this thing? So it's a shortcut to referencing the enum that I'm using. So this set pref refer release mode, right? It has a self which references itself, and then it has the mode which referencing this. So if you do dot release fast or dot debug or dot release safe, it actually look up the enum and referencing the enum value. So it's kind of a nice shortcut to referencing the enum without having to actually, so like you like the longer. So I have an experimental. My previous experimentation, I would have to do like a long giant kind of what is it? Like std dot I don't know, zig dot mode or something like that, right? You would do like a large chain of like referencing, but the shortcut really helped. Yeah. Hey, Stefan, have any question in terms of how this script look? Any question that jump up your mind so far?
I think rather than question, just like a comment is like every single build system I've used has been awful. Like in every company I've ever worked for, like literally every single one. And like when I'm looking at this, I'm like, oh man, it's not a YAML file, it's not a JSON, it's actually code. And like maybe that's what's necessary for build scripts, is like to actually have code. Like in some weird way, like you don't want to have it be abstract. Like I don't know, because I don't know, every single time I've like done build scripts has just been so painful. And like I don't know, I think like C++ has this too, right? But like what's the C++ build script stuff?
They use by the way, can you use a headphone or something, or make my volume a bit lower?
Hey, I'm muted whenever I stop talking.
All right. So in C, they use what is it? CMake, right? Or make. Basically, just a very basic descriptive way of running Bash, right? Basically, it's abstraction over Bash, which is just terrible in a way of how to. Basically, you have to learn Bash. You have to learn another scripting language to do this stuff. But I think Zig was very smart to actually bootstrapping his own build system, right? So now to build Zig, you use Zig. You can also use Zig to referencing, like when you do lib, right? You can actually also do you can add a C library too. You can actually add C library, and that's actually how one of the language server compiling their own language server using some other C library referencing. Let me open up.
Yeah, I see. For me, I think it's interesting because I don't know, like maybe if this were C, I would not like this because C is way too like low level. But yeah, maybe with like Zig it's like better, right? Maybe that's.
I can hear you, by the way. I can hear you.
Oh, oops. Maybe that's why they resorted to using Bash rather than C, because just like C is much more low level than like Zig, right? Zig is able to do this because it's so high level.
So Zig's supposedly to be faster than C, by the way. Supposedly.
Oh no, what I mean is like it does like, when you were doing like the dot, like you don't have to reference everything else, right? There's a lot of like syntax sugar. Like I'm just saying, like imagine this was like Java or like C. Like
Yeah,
it would just be really painful to do these like simple scripts,
yeah, absolutely. I think Zig has a very. That's why I usually think of Zig as very similar to Go or JavaScript. Actually, even JavaScript, it has a very. It's like it feels very simple. It has a scripting sense to it. Yeah. So far, not. Yeah, it's like especially when you comparing Zig with Rust, for example. Rust has a very gritty, very system like very complex kind of syntax. Um, but when you look at Zig code, it's actually quite simple, and people are trying to keep it very simple too. As you look around, everything is a single module, everything export a single entry point kind of style. So it's quite yeah, it's quite fun, I think. Yeah, and so here you can see that they're actually referencing some CPP kind of a C++ file, and like kind of doing some interrupt compiler between C and Rust, C and Zig.
Okay, this looks awful.
Yeah.
Line 55. Oh my god, is that like that looks like minified JavaScript.
hmm Yeah. Well, when the times you have to use some of the this like kind of specifying command flag and shit like that, right? Yeah. It's still pretty gnarly, but hey, better something than nothing, right?
Yeah, for
But
sure.
yeah, the auto completion and a lot of the tooling with Zig is still not the best in my opinion. For example, as of yesterday, renaming. So to actually make any like our code auto completion, right? So basically, for this to work, like target dot doing for this to work, right? For like I think Stefan was disconnected. Let me re-invite him again. Ooh, I think his Wi-Fi went off completely. Rip. Okay, let's make sure that we can get Stefan on. Hmm. Right. Apparently his Wi-Fi stopped working, so I'm trying to set up a hotspot from his phone. Oh man, one of the worst thing about London is the Wi-Fi. Yeah, I think one of the worst experience I have with London or the UK in general is how come the Wi-Fi is so bad? It's bad everywhere. Even at your Airbnb, even when you like staying at accommodation, the Wi-Fi everywhere. You cannot get more than 60 megabit per second for some reason. Holy hell! Yeah, I was also in what is it, Chelsea too, and even the Wi-Fi in Chelsea was barely it was barely 20 megabit per second. Like the hell? Come on! So aren't supposed to be the are they supposed to be like rich people in the area? Hmm. I wonder. All right. Yeah. Guess he wanted me to join. So I'll just finish. I'll just solo this. I'll just demoing what's happening on Zig. So let's continue with our Stefan. So we have the build script here with the specifying the target, and okay. So let's continuing from my previous talking about how Zig, one of the tooling with Zig is a ZOS, uh, Zig language server. So what's the language server? A language server is basically the backbone of how VS Code and all editor know how to do this R completion thingy. So R completion, code renaming, so refactoring code, and like auto suggestion are okay. I said that twice, but then also even syntax highlighting are some of the few thing that a language server would help would help with is a core functionality of it. So what a language server is, it basically parses the current file you have, the source file, and then it emitting. It's basically a server that emitting a bunch of data about the current file, about like whether about all of the kind of intricate like where should where should the color goes and where the occurrence of a certain item, so you can rename them. You can do refactor renaming stuff in the file, and so on and so forth, right? And basically, previously, this ZOS language server was not able to actually renaming. It wasn't able to do renaming. So basically, this didn't work at all. Previously, this doesn't work, but now it worked. Well, because apparently, um, well, uh, I think so, apparently the ZOS team did not even care about this use case for some reason, and it basically it's been around. The bug's been around for a year already, and nobody actually cared to fix this over the past year until I bring it up in their Discord server, and one of the contributor just jump on it and fix it with some magical code, and now it's worked. Very nice. So I'll probably have to dive into that PR and actually understanding what the hell is going on. But very happy now that I can actually do F2 and renaming my variable, so that at least dev experience with Zig is now at least on par, or somewhat good to play around with. Because the inability to refactoring something in my code is really I think in my opinion a huge kind of a letdown, to be honest. A cute, yeah. So here that we have the Zig build script that will actually build a library into a WASM file. So with the WASM file here, I haven't tested yet, by the way, but the idea is that now you can actually exporting the add functionality to our WebAssembly, to our web extension. Our web extension, consuming the web our oh, oh boy. Huh. I'm slipping up too much. But basically, our web extension can consuming the WebAssembly kind of a binary as a resource to run certain kind of logic, to enhance logic. So the key usage here is actually to improve performance for your extension. So if your extension is doing something super intensive, and you don't want to just run it on like the main process, and you also don't want to use like the JavaScript runtime, you actually want to use some native code stuff. This would be a fun solution that you might try. And Zig build tools are it interoperate well with C and C++. So you might be able to actually interoperate with some C++ library and outputting a WebAssembly kind of a WASM bundle to use in your extension. So actually before this project, one of the fun projects I was playing around with was actually to make a prettier plugin to for Zig actually, because previously I didn't know that Zig format was a thing. Or I saw the documentation about Zig format, but I actually never integrated it to VS Code. Apparently, it's pretty simple. After you specifying the Zig path in the one of the Zig extension for VS Code, then you have pretty much a prettier experience. It all format your code for you. So really, I kind of stopped working on the Prettier project. But one of the thought I have with Prettier though is that imagine you can actually compiling. So Zig can actually parse in Zig. So the Zig compiler parse its own code, right? It parse Zig code into an AST, into a symmetric whatever symbolic tree, whatever that is. It parses this code into AST so that it make it easier for compiler to transforming the tree into the actual somewhat Zig meta code, and then from the Zig meta code, compile that next step into the object file, into the binary. And so the Zig parser to make an AST tree is actually available from the Zig standard library. So you can actually do std.zig.parse, which is what I did for my my attempt at making the Prettier plugin. Yep. So in the parser.zig, I'll basically do I'll get the AST by using std.zig.parse, throwing the page allocator. I need to read more about what this is. I just found this code in some other example code, and then passing in data, which are the code that has been kind of spread out into into an actual kind of an allocated list or array. So this code actually doesn't work, but it's a fun experimentation on how to actually do this stuff in Zig, and kind of sending data back and forth between Zig and the main WebAssembly and the main process, the main JavaScript process, either by emitting messages as a JSON message, like JSON string message, or I found there's another way to do it, which is you use a share array buffer. So with a share array buffer, you can actually write to it back and forth from WebAssembly. So basically, we were passing in another output kind of pointer, and from the Zig source code, we just simply throwing new output into that output buffer and reading it inside our JavaScript code. So the idea is pretty fun, and I'm actually excited to actually play around with it more and actually implementing that kind of process, kind of logic. And then this Prettier plugin Zig kind of project is kind of get a blocker right now. The key blocker is that Prettier plugin can only do at the moment with 2.x with 2.0. Prettier v2 does not support asynchronous printer and parser, which are the two key components for Prettier to actually parse the code and print it out in the print like the Prettier version. And basically, to run a WASM binary, to run a WASM CAD runner, you have to fetch the WASM code, turn it into array buffer, and then instantiate it and run it asynchronously. So because the current parser and printer does not support async, it only do synchronous. You cannot really do that. You cannot really run the WASM parser like as is. We have to basically de-async the WASM instantiator to instantiate all the WASM stuff synchronously and run synchronously within a single thread, which is okay. It's doable, but I think I don't know. I found the Zig formatter work kind of fine for the current usage, and people probably just prefer to use Zig formatter anyway. And this is a fun hack, but it might be a huge. I think translating the Zig AST to the Prettier AST gonna take a long while, and I don't want the. It's a good kind of fun project to experimenting with Zig and kind of have fun with it for a little bit, but at the end of the day, I just want to use Zig to have some fun, and so I didn't want to dive too deep to that. So the project is halted for now until Prettier 3. Prettier V3 would actually support an async parser and printer, and that might be a good time to revisit this project and see what's up with the with the Zig AST. For now, I think we have like a kind of a simple path forward to compiling and creating our own kind of Zig WASM bundle. In the future, perhaps you can actually importing a Zig logic file and don't even have to worry about the build of Zig. We can actually embedding this build of Zig or make it into a standalone like Zig execution runner on our own inside the Plasma framework. We can ship that inside Plasma. Even funnier as a WASM runner. That might be fun. Or we can just either as a WASM runner, or we could just invoking the Zig compiler internally too, stuff like that. That'd be fun. And so you can actually referencing a Zig file inside your content strip or pops up or background, and then you can actually instantiate a WASM bundle from that. Yeah, and that will actually allow you to have like high performance web extension with very little boilerplate code, because all the boilerplate stuff like this, and then those stuff we can handle it for you, right? We can just we can bootstrap that for you, so you don't have to worry about that stuff. So that'd be fun in the future to think about. Yeah. But anyway, I think that's about it for our Plasma demo. I think it's demo number 17 or 18 by now. Not sure which number it is, but hey, thanks for tuning in. Too bad Stefan couldn't stay for too long, or I mean his Wi-Fi just sucked. I'm sorry, Londoner, but yeah, you guys really need to fix your Wi-Fi. Anyway, that's pretty much it. Have fun and see you.